Physical AI is where GenAI models and NNs transforming instinct into response, and this is a new discipline, and the next speaker is going to talk just about that. Please, a very warm welcome, CEO of Navio, Grigory Forostovsky. Physical AI technology, the name of the presentation.
Друзья, всем привет. Меня зовут Григорий.
Hey everyone, my name is Grigory. I'm a CEO of Navio company. Today, I'm going to talk about GenAI.
Физический мир. То есть мы
How it comes to our physical world. We are living in very exciting times. The times that start changing very quickly. We can see GenAI in various areas of our life. Today, you have seen a dancing robot. You have seen GigaChat today as well.
воплощение.
But today I'm going to talk about physical AI technology and physical relay for the AI technology. 2025 was a major year of major shifts for our company. Everything has changed. The way we work, our technology landscape, our products. But currently we do not see even one commercially successful product. So today I would like to explain why that happens and why we don't see driverless cars on the roads. How many of you, raise your hand, how many of you have come here on autonomous vehicle, on driverless vehicle? Well, maybe I was the only one, because I work on that. Our industry started in 2009 when Google launched its first driverless cars. For the first 15 years, the industry was very promising and exciting. All the industry said that in 3 years, every time they said in 3 years, the trucks will be driverless. We will go around by driverless cars. We're going to use driverless buses to commute to work. But unfortunately, it has never happened. Now, my task today is to tell you why we failed to deliver, and why and how the industry has changed, and what started to appear, what new developments we started to see as GenAI was ushered in this area. Now, the industry in 15 years, one slide, more than $50 billion were invested overall. The US, Europe, China, and Russia have created more than 10,000 driverless vehicles. More than 30,000 research papers were published, and there were 0 commercially successful products. And I want to talk just about that, why that happened, how the industry will change, and what will be the next steps. Before we go there, I'm going to show you a couple of videos, and I'm going to tell you why, I mean how the experts of the industry see these changes, and I'll show you some of the leaders like Waymo, Baidu, and I'll show you what were their success stories until 2025. Andrei Karpatov, a very famous scientist, he for some time headed AI in Tesla, and he was one of the co-founders of OpenAI.
About a 30-minute drive around Palo Alto, highways, streets, and so on. And this drive was perfect. There was 0 interventions. And this was 2013, which is now 12 years ago. And it's kind of struck me because at the time when I had this perfect drive, this perfect demo, I felt like, wow, self-driving is imminent because this just worked. This is incredible. But here we are 12 years later, and we are still working on autonomy.
Да, то есть здесь Андрей рассказывает.
Right, so Andrei is talking about how he was driving a Waymo car in California in 2013. The car went around the town. They were driving for 30 minutes, made all the turns, and he said imminent. Imminent meaning that, okay, like in a couple of years, this technology will become ubiquitous because the car was doing everything. Google 2024, a Waymo car, an industry leader, lost the point. I'm going to talk about the maps later. It has lost it, and you can see the person inside.
Yeah.
Bear with me while I am.
Yeah, I got a flight to catch. Why is this thing going in a circle? I'm getting dizzy. Look at what it's doing.
I understand. I'm really, really sorry, Mike. We're currently working with the situation of the vehicle. Is it circling around a parking lot, right?
It's circling around a parking lot. I got my seatbelt on. I can't get out the car. Has this been hacked? What's going on? I feel like I'm in the movies.
Scab calling from Waymo.
Да, вот еще мой один из любимых таких.
Right, and this is another favorite video of mine. I will let you know why I'm doing this, why I'm showing all these videos to you. So there's this guy with a stop mark on his T-shirt, and he found out that all these driverless cars stop when they see him, when they see the mark. And my own example from my own personal experience, I went to China at the invitation of Baidu. They have one of the biggest autonomous car parks in the world, 1,500 driverless cars in Wuhan. They showed me the technology, their cars, and 3 minutes later, this happened. The car wrongly detected an object, and it drove into the solid lane markings area and just stopped. It thought it was standing at the traffic lights and it thought everything was fine, so it's not detecting an issue, it's just standing there. It doesn't understand the environment, the context, it doesn't know that I need to go somewhere, it just stopped and wasn't budging. So a person had to intervene and start driving. Why is all this happening? Why are we and the whole world investing a huge amount of resources and time and money into it? And we achieve this point where technology fails to solve banal, simplest issues. Let's have a look at a couple of lines of code. It's very straightforward, a very simple scenario. It's based on an algorithmic approach. When we are writing a code, we do this manually. Each action of a car is written manually as a code. It says here, if you see a pedestrian, stop. If you see another car, stop. It's very simple. But if we start writing code for everything that might happen in public roads, we can look at this code scrolling down for 15 years, and there will still be more code. There is this term in the industry, long tail. The long tail problem, what does it mean? First, it starts very quickly, very easily. As Andrei Karpatov said in the video, he said 2012, 2013, Google was taking leaps forward, and there were driverless cars in the streets of the cities. They took another step forward. They invested millions and millions. Okay, we have code for everything. What else can arise? And then we have this guy with a stop mark on his T-shirt. And the car fails, it loses its point, it stops unexpectedly. And this is just San Francisco. So there are more and more scenarios coming up, and you cannot code for each and every scenario manually. You can't code for anything that might happen in the world. You go from San Francisco to Moscow, and you have new cultural context to factor in, new signs, etc. We've been writing this code for 15 years, and we're still not finished. So presumably, it's not even possible. But it's not that bad. We have a new approach. based on GenAI that I'm going to talk about. We see that the industry is changing very rapidly. Since 2024, and this is one of the examples, Tesla has started to deliver cars. You buy a car online, you click the button, you pay for the car, the car leaves the factory, and it goes straight to your house. Tesla also launched this taxi service in Texas. They invested $5.6 billion. Wave is this new startup from 2018. They started off the article called "Attention is all you need," and they decided to develop their own software on AI algorithms. They decided to take GenAI, transformer architecture, and decided to build their own software. And as of today, or rather at the end of 2024, they announced that they would bring their cars to 500 different cities across the globe, and then they will start the car, and without any preparation, the car will drive around each one of the 500 cities. Then Baidu started to scale up their business in China, and so on and so forth. Those are just some of the examples. 2024 became a year of a lot of changes and disruptions. We saw that a lot of tech companies started to scale up their business very rapidly, changing very rapidly. Let's have a look at the changes. What I told you in the beginning, the algorithmic approach. Let's have a look at how it works. Sensors have cars, radars, cameras. All of the information they collect goes to the block called perception, the perception of the environment. This block reads the information and sends it down the line to prediction and planning, along with high accuracy information from maps and localization information. I highlighted the blocks called prediction and planning. When they worked based on algorithmic approach, you had to program each and every action of a car manually. I told you why that doesn't work, but it's not that bad. What Google started to do, and Baidu and Yandex back in 2024, was they started adopting GenAI models, and they started integrating transformers into their technology. We took the problem-fraught block, we integrated a transformer into it, and started to train that block with a transformer and with information about human behavior. And then it started to handle complicated situations like accidents or unexpected emergency situations, but still the guy with a stop sign on his t-shirt is still a problem. Why? Because to solve that problem, the car needs to be able to understand the environment, the world. The developers said, we can train the perception block to make it perceive that guy with a stop sign and make sure the car doesn't stop in response. We tried to do this, and we see that there is the stop sign, there is a person nearby just smoking a cigarette, and the block perception says, do not stop. The conclusion from this is that to solve the problem of self-driving cars and to implement this en masse, next time I ask you this question, who drove here in a driverless car, hopefully we will see more hands. Hopefully we will have had people who used Navio or other cars. We need a technology that understands the world. This technology, at the moment, is VLA, as many companies, including ours, find promising. I will briefly outline how this works and how we are creating this VLA. We take Sber's model, and based on this, we create the VLA model. So Sber has GigaChat, the LLM model that works with language. Then the model turned into GigaVision. Andrei Belevtsev talked about this today. This model is called VLM, Vision Language Model. We took that model, we fine-tuned it, and turned it into VLA. What does it enable you to do? So we do driverless cars, but this approach, this model, can also be used to control robots, drones. You saw a dancing robot today. It's a sophisticated model. You didn't see drones today, but you can imagine how they work. So this approach works for everything. We apply this to transport, but this architecture can be applied to any physical object. Let's have a look at the technology in more detail. How does it work? We collect big data from the world, text, audio, video, labeled data, data that we put into a car to make it distinguish between a person and a sign and another car. We pack it into a big data set, training data set. We fine-tune the model, or rather we pre-train the model. It's a generalized model that you can use at a later stage to create applied technology. And then we have our VLA model, which we fine-tune with reinforcement learning and all kinds of things, lots of fine-tuning methods. I will not give you the details of the architecture because we do not have the time for it. We have a photorealistic simulator that helps us test and validate the models, but we also use synthetic data to train the model. Complex data from the world, Moscow, for example. I'm sure you've never seen an elephant on the roads of Moscow, but in Thailand, you may see it. We don't want to go to Thailand and collect data there. Instead, we have the simulator. We can create or recreate this scene, this environment, and use it to train the model. And then, importantly, this part called optimization and distillation. Before the model reaches a physical object, they work without connection to the internet. This model runs on a small computing unit to make sure it works efficiently with a low latency. We need to optimize the model and to make it small and powerful. It's a very big area of expertise. And then this optimized model with the reasoning, with the understanding of the environment, can be used to control all kinds of physical objects. Navio used the model to control transport. Starting in 2024, we started to integrate GenAI into our solutions. We were doing mainstream cargo transportation, and we had successful solutions there based on the algorithmic approach I talked about in the beginning, but we couldn't make our cars drive in the city. 170 driverless cars running around the city, but not in commercial operation. This year, we have done a number of breakthroughs, incredible technological breakthroughs, and now we know that this technology can help us bring our products, taxi cars, buses, into the urban environment, onto city roads. I'm sure you've noticed our bus, the shuttle bus. I would like to show you a video of it. It's not a mock-up. We have several cars like this. We've been testing it. It is there driving along city roads. I want to show you what GenAI enabled us to do with our products.
Всем большое спасибо.
Thank you very much. A round of applause for Grigory Forostovsky.